These are in listen-only mode.
Hello, good afternoon, and welcome to another Open PHACTS webinar. I'm Nick Lynch, and I'd like to thank you all for coming today for the restart in our autumn series of webinars. We're delighted this week to be covering some of the chemistry components that were developed as part of Open PHACTS. We are recording this webinar so that people can listen to it later, so just to let you know that we're recording. And equally, if you want to get in touch with us later on, then by all means do so, either by email or Twitter, etc. And we'll also be making available the presentation and this recording after the event. We're delighted this week to have two speakers who contributed a lot to the chemistry components of Open PHACTS. Both Antony, when he was at the RSC, and previously at ChemSpider, did a lot around the early designs of Open PHACTS in terms of the chemistry business rules around normalization and standardization. And equally, Valery, who is at the RSC too, still at the RSC, contributed both in his ChemSpider role as well as being the key developer in developing these components which now exist in Open PHACTS and are also available. We'll hear more about them in a minute. So let me hand over to Antony and Valery and thank them very much for today's webinar. As I change presenter, just to let you know that if you would like to ask questions in this webinar, you can do it in two ways. You can either raise your hand in the little app that you've got, or you can type in a question. And what both Antony and Tony and Valery have agreed to do, that if there are questions that come in and they look relevant, that we cover them there and then we'll jump to you there, quickly, so that we can have a good discussion. Otherwise, we'll do the rest at the end, and if you do put a question in, we'll also try to go to you in audio, so we'll try and unmute you at that time. But any other questions, by all means, put a question in, or any problems with the audio, do let us know. And I'll hand over to Tony and Valery, and thank you very much for today.
Thanks very much, Nick. Appreciate it. It's very nice to return to one of my old stomping grounds, which is around the Open PHACTS project, and collaborate with Valery putting this together in the past couple of days. So I am at the EPA, and it is very interesting how small the world is in terms of needs for cheminformatics. There is a particular reason that I'm choosing to participate in this today, because some of the problems that we face with Open PHACTS and with ChemSpider continue to haunt me, continue to follow me into my new role. So today we're going to give an overview of where everything got to with the chemical registration system and Open PHACTS. Valery's going to give you an overview of that. And then my focus is going to be turned to the chemical validation standardization platform work that we were doing, and how we're thinking of taking that to embrace a larger community of involvement, and some discussions that have started up with some of the larger organizations in the world that will concern themselves with this. I'm going to turn over to Valery for the first few slides of intro, and then we'll touch back on CVST. Over to you, Valery.
Thank you, Tony. Thank you, Nick. Okay, so let me give few bits of technical introduction of what CRS. CRS stands for Chemistry Registry System, and it's obviously the part of Open PHACTS Discovery Platform. Open PHACTS Discovery Platform has been developed to reduce barriers to drug discovery in industry, academia, and small businesses. As such, to fulfill this duty, Open PHACTS Platform assembled the data coming from absolutely disparate and different data sources. Part of this data is chemical, part of this data is biological. The Responsibility of CRS as a chemistry registry system is to deal with all chemical information, including chemical itself and PHACTS data that is associated with these chemicals. The gluing chain of how we connect PHACTS data belonging to chemicals and the pharmacological data belonging to biological substances is through identifiers. So part of responsibility that CRS is bearing is to support and maintain the curated list of identifiers which are later used to connect different entities from both chemical and biological sites. Next slides. Yes. So the red rectangle was outlining the responsibility of chemistry registry system. It's only part of the whole overall Open PHACTS platform. So what does chemical registry service provide? Broadly, it can be split into three main areas. First of all, we do chemistry processing. We load chemical data coming in popular cheminformatics formats like SDF file format. We validate, we standardize, we generate properties. We also are able to retrieve properties from third-party systems like ChemSpider and some other use of their APIs. And that all belongs to the chemistry processing pipeline. Once all the substances are passed through the pipeline, we are able to export all the data that we validated, standardized, curated, pulled the properties for. We do export in two main formats. First of all, it's SDF, so same format that came in, but we add additional information that we received during the processing stage. We also export as RDF in a triples form. That information further goes down to the Open PHACTS discovery platform. Also, the third part of our deliverables is because chemistry domain provides very specific chemistry searches, and I'm speaking here about subtraction and similarity searches, which are not alphanumerical searches and has to be done in a very specific way. We provide the platform for running those chemistry-specific searches through the API. So we expose from the chemistry registry service. The third of our deliverables is API. And API covers both the domain-specific searches and generation of images of chemical structure and displaying the properties and doing some on-fly conversions, like from one form of identifiers to another form of identifiers. Next slide. This a bit complicated picture is here just not to talk through details of architecture, but to designate that what sits behind chemistry registry service, it's quite a complex system, distributed and which is deployed as a set of different databases, web applications, and backend processing pipelines. Next slide, please. CRS consists of the following system. It's CVSP itself. CVSP stands for Chemistry Validation and Standardization Platform. It's basically the deposition gateway into CRS, and the deposition gateway which also allows you to validate, standardize, review, curate the data before it gets finally deposited into the database. Compounds database. It's where all the information resides once it's passed through the deposition gateway. API, the specific part of the system which serves third-party requests from the Open PHACTS platform and potentially from other attending parties. API request for retrieving the chemical information for running domain-specific searches that I mentioned previously. Data sources registry, because every data that's coming into CRS is being registered against some data source to keep all the provenance of where the data came from. We also have a component inside the system which is responsible for tracking the origins of the data. Sometimes most of the deposition that we dealt with are rather smaller. By small I mean it's few million records in size, and those depositions can be easily processed with a pretty regular hardware. But sometimes the deposition that the system is dealing with are huge, and by huge I mean tens of millions of records. For those size of the position, there is a possibility to expand the processing capabilities by adding additional processing machines, and this is processing farm, which is optional. Next slide, please. And I think, Tony, I'm at this stage. I pass it back to you. Tony, you're on mute.
Yes, I was. Thank you. I was talking. So Larry and I have been working in the domain of linking together databases for almost 20 years in a commercial world with ACD Labs, and then we did ChemSpider and then RSC, and now I'm back doing this again at DPA. And one of the things that we collectively have worked on, and we're not the only ones, of course, you have to take into account the efforts of EBI and PubChem and Drug Bank and so many of these databases. To link everything together, we develop mappings. Those mappings can be based on many things. We can use CAS numbers for mapping. We can use trivial names, systematic names, INCHI strings, INCHI keys, smiles. All of these things are mapped between databases. The issue that we find is that while this may be easy for common chemistry, there are many edge cases that can affect many percent of the databases for getting the mappings correct, and it's because the databases that are hosting this structure information, they use different processes for standardizing. They use different tools. They may be commercial tools, they may be open source tools. They have different rule sets that they've encoded against those particular processing standardizers, and that becomes a real issue for mapping these databases together. And considering only public databases, such as the EBI databases, Campbell, KEBI, NIH, PubChem, ChemSpider, and our own databases now, we do see a lot of mismappings occurring. We want to try and resolve some of these issues because this was very important as we brought up Open PHACTS. This is an old slide, but just an example of taking an old version of Drug Bank. I cannot confirm that this is still the case with Drug Bank because Dave Wishout and his team are regularly incrementing the way that they process data. But downloading Drug Bank 3 or 4 years ago, we found that the series of records, there were aromatization issues, and there was no easy way to de-aromatize them so we could get the correct mappings. We found about 40 records in this old Drug Bank collection, which was about 3,500 chemicals at the time, where the INCHIs did not match the structure that was actually on the database. We found records where the smiles, the INCHI, and the name did not match the structure. We found examples where the records with stereo bonds, 2 stereo bonds with a chiral atom, which goes directly against the UPAC recommendation about how to represent structures. And this is just one database. We were trying to map together many databases. On ChemSpider now, I think there are over 500 data sources. So these issues came up regularly. The work that we are going to discuss on the CVSP standardizer, the chemical validation standardization platform we did for Open PHACTS, we weren't the first. We certainly are not the only one in town. There are many others that are starting to show up, and this is just a short list. EBI has one online now called EBI Standardizer. There's the PubChem Standardizer, and that changes incrementally with time as they improve their rules. I came across another one last night called the NCGC Standardizer, and of course there's the work that we have ourselves with. And the one I'm going to focus on is the one that is available publicly, cvspider.com, the one that I've continued to test out. But there is another version that Valery has pushed out, which is a later iteration of this. The reason I've focused on the public ChemSpider version, CVSP, is because any of us can go use that today. This has been published already. You can find this in the journal Cheminformatics. It was an article that we published in 2015, and so feel free to go look at that in more detail so you can understand some of the more detailed opinions and comments and approaches that we took. We won't be able to cover all of those today. When we came at this problem, it just so happened at the time that we were in discussion with the FDA, and we referenced their substance registration system. They have a standard operating procedure that I was looking at, and this came up from a conversation, as I recall, with John Hollerton from GSK, and also Lee Harland was aware of this. We went into this document in some detail and reviewed it. You can find this online. It was originally published in 2007. This particular document became the guidance for us to do standardization, and we adjusted it as appropriate for the needs to deliver on the project. Just some very quick examples of what you can find in that document. And it's a very, very long document with lots of details. And I'm sure they've actually extended on that internally as they've gone through the process, but I don't think there's a later version available publicly. And here's a typical example of how would you want to depict nitro groups for a viewer? How would you want to deal with things like sodium acetate? Do you want the covalent bonds? Do you want the charge form? These are just two simple examples that we're all very commonly aware of. The CVSP system, as I said, can be accessed. I was working with it last night at cvsp.chemspider.com. This is the entry page. In order to submit through here, you would actually need to register and log yourself in with a name, password, standard registration system. Then, as Valery highlighted, it supports various formats, so you can push through CDX files from ChemDraw, you can push through standard mol files, and you can zip a whole set of these, an SD file. The system is limited to about 40 megabytes at the moment, and as it says directly on the screen, the zip files should contain files, not folders. So you can submit a gigabyte of data if you want. It just has to be chunked into 40 megabytes or less. I want to point out the fact that we are using this actively at the moment for me to test out some of the capabilities and some of the challenges that we still have. The database that I'm building, which is publicly accessible, already has 720,000 chemicals on it. And even in our own database, even though we commit to it being highly curated and having the correct systems in place, we are using our own standardization processes inside, and we are already seeing collisions with other public databases. So what I'm starting to do is push depositions through before I put them to our own dashboard. And recently I had the pleasure of working with my colleague at RSC, Dave Sharp, who I said, we're going to push our entire database to you, Dave, so to put on ChemSpider, because all of our data are open. Could you please check on your side what you would see if you were to go through your own process of filtering our data? So I passed the files, 720,000 chemicals over to Dave. He did his work on his side and handed me back a set of chemicals which he said had issues with ChemSpider. I then submitted that set up to CVSP, one SDF file, and submitted it, and within a few minutes I had the ability to review this. So this is what you see in the interface for that particular data file. The CVSP platform is going through and it's checking the chemicals one by one against a set of expected rules and standards that we have, and it gives you a nice user interface to review this. And this is highlighting the fact that there are 98 errors, 1,571 warnings, there's information about the other collection that remains, and then all records is 2,453. And so you have the ability in this interface to do advanced filtering. You can see my cursor. You can click on here. You could go into deeper filtering level. I won't bore you with all of that. I encourage you to go try it. But what we're going to do is we're going to look at the 98 errors. And here are some examples where it is saying that for this particular chemical form, it contains one radical. Sodium is highlighted here as a radical, not neutral, but as a radical. In this second example here, we have an oxygen that is a radical, negatively charged and a radical. And I can get to see what each of these one at a time, browse through them. I can download this as a data set to continue working with on my desktop, etc. This is a very nice way to iteratively catch some of these issues. These are only two of the chemicals from the error set. The validation rules that are used, they are a default that we set up by consulting the SRS document, by having discussions with people working on the Open PHACTS project. This is an open rule set. It's available as an Excel form so that you can download it. What we are hoping is that people will actually adopt this rule set, give feedback, and we continue to improve it iteratively to get to what we could call a common ground, so that the pharmaceutical companies agree that this is a good default set, so that the public databases get to the same place. So this is the default set. However, there are also other alternatives. We have default CVSP rules for how acid bases are dealt with. We have a rule set for standardization, which comes after validation. The chemicals that don't pass our validation set can be standardized into a more general form. I will discuss that in a little more detail shortly. We also have my own set of rules, because I can actually upload a set of rules that I would like to use on this platform. I've never personally done this, but we did configure the system to allow this capability, so that since CVSP is an open source system, since it can be used inside different organizations, you may choose to have a specific set of rules that work for you, but you may use the default set of rules to release the data out to the public. This is an old review of Kemble when it was 1.3 million records, and when we pushed Kemble through in those days, I can't say that these observations would hold true today, because EBI do an excellent job of improving their own standardization process. But in this old review, we found 11,000 records with 4 bonds and 0 charge, which did not, I think these were nitrogen centers. We also found hypervalent oxygen, carbon, boron, etc., etc. Some of these may turn out to be valid, but the validation review process itself allows you to look at each of these and see whether or not they should be passed through. And then we found over 6,000 records where the stereo bond direction didn't actually make any sense. So the chemical validation process is what comes first on CVSP, then you choose to standardize. And what standardization does is it fixes them according to the rules that we've encoded based on the SRS document, as well as feedback that we got during the development of the project. And it's a set of SMERC transformations, and it uses both INCI normalization approaches as well as the FDA SRS rules, as I mentioned. So I won't go through these in details, but we have an INCI normalization rule at the top for the SMERC transformations, and we have the FDA SRS rules at the bottom, again with these transformations in place. And there are many, many tens of these. They are available. You can view them. You can download them. And I believe they're attached to supplementary info to the Journal of Cheminformatics article. These are examples of standardization.
Tony?
Yep, Nick?
Sorry, it's Nick here. Since it's getting to a point where there's a couple of questions that might be quite good to answer if you're okay with. So one was from Dimitri at J&J about what chemistry toolkit does the standardization service use? I can answer that, but Valery, you might want to answer that more directly and what your thoughts are moving forward.
Yep. The current implementation of CVSP uses Indigo toolkit from used to be GGA, now EPAM, but there is no real affinity to a particular toolkit, because of what we are using there is just support of reaction smarts, which we then pass the chemical structure to and retrieve the results. We are planning to provide support for more cheminformatics toolkits like CDK and RTKit in the future.
And then he also asked if you've ever looked at handling biologics, which I presume he means by sort of larger molecules.
As amino acid sequences, or?
Yeah.
Well, it's not, the CVSP was developed for providing support for chemicals, small organic molecules with a molecular mass up to 500, 1000, whatever, so what can be represented as connection tables. But I can see the value of systems like this to validate and standardize representation of biologic substances as well. It's just not in the system.
And maybe, Dmitry, we can, maybe that's another chat. I'm happy to talk to you about other standards that exist in there, because there's also a Helm standard which also might be relevant to what you're asking about. So maybe that's even another discussion at some point. And then Dmitry also asked about standardization of tautomers, which was perhaps what you're about to come to. So I'll let you maybe cover that when you want to.
Actually, I think I removed those couple of slides just because of time.
Oh, I'm sorry.
But yeah, there is, the system does try and collapse to the most favorable tautomer, and I can make sure that those slides are made available. I can point you to those after this session. But I don't think I have those slides left in just because of time.
That's okay. No, thanks for that. Yeah, I'll say if it's okay, we don't have any more at the moment, but I'll keep coming in if there's any others that seem particularly relevant at the time.
Yep. And there, as you say, there is Helm for the macromolecules, but there's also an effort that goes on at the FDA that Valery is aware of, called SPL. I'm not sure whether that would connect into this. I'm not sure whether you're aware of that, Nick, but that's a separate conversation you might be interested in also.
Yeah, we should definitely have that. Okay, thanks.
Okay. So this is an example of standardization where the SRS rules as well as the UPAC rules would encourage you to not show ambiguity or the double bond orientation by putting a wiggly single bond, and standardization will convert it into this cross bond form. Some of you may disagree with that, but that's why we need to get to a common community agreement of how these things should be handled. The best comparison I could give is INSHI has a lot of capability and variation that's possible, but the community came together around the standard INSHI, and it did clean up a lot of the mappings that are possible. The standard INSHI has its own issues, but at least it's an agreed upon set. The same thing needs to happen, we believe, around standardization. The second example here shows collapsing the hydrogen atoms where there's no stereo bonds, just as an example of improving the depiction. Here's another example where you want to remove symmetric stereo sensors. There's no value to them, and also turning off the chiral flag if there's actually no up and down bonds of value in the representation. So as I started with, there are at least 4 standardizers. I believe there are others. There's things like MolVS, and I'm sure that we have our own 9 workflow that we use for standardizing chemicals before we do QSAR modeling. That was developed by Kamel Mansouri. I'm sure people like Alex Trocha has a standardization system. Then there's the original Cheshire. There's the Chemaxon standardizer. So there are so many of these things, and they each have their own rule set. And as we apply them, we end up with a lot of overlap for a large set of chemicals, but also a whole lot of edge cases that are problematic. So would it be possible to decide on a default community rule set, like standard INSHI, that could be used by all the standardizers? Of course, you have control over what's possible, but in your own environment, but choose default, and we would end up with the overlap that we would hope and expect for. With this in mind, there was a meeting here at the EPA. I work in the Research Triangle Park in North Carolina, so a group of people came from around, from Europe, from around the US, even as far afield as New Zealand. And it was the people involved with the Research Data Alliance, UPAC, and the ACS Division of Chemical Information. Came into a room, we spent 2 days working on a number of projects, and one of these was the possibility of coming up with a community rule set that could be adopted into standardizers. To be honest, this project has not moved forward as fast as we would like, mostly because the people who come into those rooms are all busy people, and they all go back to work. But there is an intention to have something released on this, hopefully in the next 2 or 3 weeks for feedback. And I'll be putting the first document together on Google Docs for discussion. Meanwhile, because of my previous involvement with CVSP, my proximity to Valery geographically and the fact that I think the CVSP is heading in the right direction, and some discussions that happened at that meeting in July. We here at EPA are investigating CVSP as a validation standardization platform. We have our own already, but we're considering adoption of one that may actually be more adopted by the overall community. We are considering specifically the API aspects of CVSP so that we can connect it to our own registration system that we have internally. We're a lot smaller than PubChem. We're a lot smaller than ChemSpider in terms of content. We're trying to produce the most highly curated, appropriately matched set of chemicals of concern to the environmental sciences domain, because we're the National Center for Computational Toxicology around environmental chemicals. So we're intending to integrate this to our own system. And we also believe that this could be a reference implementation and a good starting point for a community rule set. The set that are already there as default may well be the best starting point for community rules. And then we engage the experts in the field for feedback, and we try and improve that rule set. Valery, I'm going to hand over to you, if you don't mind.
Yep. So the CVSP as a chemistry validation and standardization platform was developed by RSC for Open PHACTS, and it was completely open sourced last summer. The code is released under this URL and is available for everybody to download. The system was written in C# in .NET platform, and yeah, that's it. RSC has developed and delivered CVSP as is to the community, and there is no plans for further support of the system going forward. I still can see the great value, as Tony has just talked about, of this project and of the whole movement with the chemistry standardization validation. So I will, in my spare time, I will offer the support for those who may be interested in using this platform. Next slide. So CVSP was delivered as open source, but it also was delivered as a set of virtual machines where the whole system, because the original diagram, architectural diagram of the system shows is pretty complex, while compilation of the system is easy. You just load in Visual Studio and run the compilation. The deployment of the system is not that trivial. So we've shipped 3 virtual machines with pre-installed versions of all the components that comprise CVSP. And those are front-end machine with all websites, where all the websites are residing, including the API website. It's back-end machine for all heavy lifting and processing, and database machine. Those images are VMware images, but it doesn't bound them to VMware hypervisor because it's just a disk images and can be converted between different hypervisors pretty easily. I believe that's it. Unless there is a next slide. No.
Yeah, so we've tried to give you a summary of our activities, historic activities around CVSP, the status of what's being released as open source to the community, some of our thoughts around how valuable it would be to come to at least an agreement around a community rule set. CVSP may be a good starting point as a platform to test those rules, but of course there are so many standardizers. We would hope everybody with their own standardization platform would get value out of a community agreed set. Conversations are ongoing with that, and that's pretty much what we had to cover today, Nick. Hope this was of value.
Yes, thank you, both of you, for that great summary. I know we were covering questions a bit as we were going along, so equally if others on the call would like to ask some more questions, either raise your hand in the application or type in a question and we'll jump to you. And equally, if Dimitri, if you wanted to ask any more, just raise your hand and we can unmute you if that would be useful. Whilst people think of questions, maybe it's worth picking up on the point you made about the RDA meeting in the summer and maybe some of the next steps, because I myself, and I know some of the people on the call, were at a meeting, a MIOS meeting that Mark Forster arranged with the EBI industry program in May time, I think it was. And I think equally there was a lot of interest in trying to think about the future of coming up with maybe a common standardized rule set or requirements. Tony, do you think that those two activities could be, that there's enough momentum now maybe to build on both of those meetings?
So there was definitely momentum coming out of that meeting, a lot of excitement, and as is an unfortunate situation with all of these things, when you come together in a room and you have a chance to focus, things get very heated in a good way. You get a lot of excitement, and then we all go back to our jobs, and that becomes the primary distraction. It is on me to actually assemble a basic document, because I've spent some time last night putting together these slides. It's kind of kicked me back into action around this, and I'm committed to try and get something back on Google Docs for the people who attended that meeting. We should never go it alone. If there are other passionate people with the same view of what we need rather than necessarily how to get there, we should bring those discussions together for sure. We should have one common goal and a distributed team of experts to be involved in getting.
No, yeah, I can certainly the energy at the earlier meeting, I think, probably fed into yours, and I know that from an Open PHACTS perspective, we'd be very keen to see that work progress, and certainly willing to help from our side. And I think certainly equally with the European hat on here, I think there's a lot of energy from the different groups within Europe who were perhaps there, given its location, to see that going forward.
Interestingly, Ian Bruno was here from the Cambridge Crystallographic Group, and he sent an email just last week asking that we get back on a regular schedule for discussion. So that kicked last week, and then preparing for this today. I'm definitely interested in trying to get things moving. And of course, I'm only one cog in a very large engine, so I'll get things moving. Let Leah know, Leah McEwen, who's involved, and Evan Bolton, Ian Bruno, etc. And we'll try and pick this momentum back up.
Yeah, no, that would be great. And not wanting to speak for others, I know, after that we had a couple of calls with Greg, Landrum, RD Kit, and Andrew at EBI.
So Valery and Greg were connected. We had great discussions here in July. And then I think Valery, you've tried to connect with Greg since then, and we certainly got to a very common ground. That's why the discussion about getting RD Kit as an alternative to the Indigo toolkit was actually up on the table.
Okay. If it's, I think Dimitri's asked another question, so rather than me, I'll try and unmute you, Dimitri, and maybe you can ask your question about the tools that you've just asked. Dimitri, can you hear us? Oh, is this going to work? Well, maybe I'll ask it on his behalf if Dimitri can't hear me. Dimitri asked about the fact that you were using Microsoft Studio as the compilation tools for the toolkit. Is there anything you want to mention about that, given I suppose that or ways that could be used still in an open source way, without?
Well, the Microsoft provides Visual Studio Community Edition, which is absolutely free, and besides .NET Framework, as all frameworks come with a compiler, which is UI-free environment where you can just run it in command line and compile C# code. So there is no heavy binding to .NET or Microsoft technologies other than the fact that it's been developed in C# language and .NET platform, which, as probably you know, was completely open source just recently and now called .NET Core. We run on multiple operating systems, including Linux and macOS and Windows, obviously.
Okay.
I wonder if you can actually hear me now. I think I accidentally pushed on the mute button on my microphone.
We
Can you
can,
hear me?
yes. Yes.
Yeah.
Did you hear that response from Valery?
Yeah, I'm very familiar with Microsoft tools because I use them all the time, you know, personally. But regarding the toolkits, if you replace one toolkit with the other one, like for instance Indigo with RD kit, then lots of things actually change. In my experience, all those idiosyncrasies of particular toolkits as to how they handle certain chemical structures, non-trivial chemical structures, I mean, so it changes standardization considerably in many cases. So if you're kind of relying on a particular toolkit, then switching to a different toolkit will require total re-standardization of your entire chemical repositories, whatever you have. So that's my experience. Because trying to kind of curate certain chemical structures is quite a big problem. So we usually like re-standardize everything if something changes in the toolkit.
That's definitely true if you are using these toolkits off the shelf, as is what we try to do in CVSP. We've broken down our standardization rules in a long set of atomic rules. And yes, you still can say that there could be discrepancies in how various informatics toolkits are handling these atomic rules, but it's much easier to control it in this way than, you know, trying to use the whole standardization procedure out of some particular toolkit as is.
Yeah, and I would probably vote for RD kit because it's open source and comes with no binding license as far as I remember. Indigo, I think, has a dual license. It's open source / commercial, at least it used to be the case a couple of years ago. So if you want commercial support and deployment in the production environment, you actually have to apply for a commercial license.
Yeah, that's what we heard from Greg when he was here. He was encouraging the shift to RD kit for exactly that reason. He would like to see things freed up a little more than the binding that you have with Indigo.
Even though I can say from a developer's perspective, both toolkits are very well implemented. I mean, I've looked at the code, at the source code, and the people who develop both toolkits, they do know their stuff, you know.
Yeah, we made the decision specifically Indigo because ChemSpider was built using that as the original toolkit. ChemSpider still runs on Indigo. We had a lot of experience with that, and it was the most appropriate path for us in the time we had available to deliver the solution.
And by the way,
we're out of the project, but, you know, we can make alternative decisions.
And probably the last technical question: do you use Microsoft SQL Server in backend?
Yes, we do. We do, but we use it through the entity framework library, which in theory an entity framework was a code first option. So what it means, we define the business object in C#, and then the entity framework does the work, ORM work for you, converting the particular database schema. Right now there is a support for Postgres and for MySQL and some NoSQL databases in entity frameworks. So again, in theory, the database layer can be migrated to other database platform, including open source ones.
Yeah, as you know, Dimitris Agrafiotis, whom some people probably know in the school, he loves to quote this. He says, in theory, there shouldn't be any difference between theory and practice, but in practice there is.
Yep. Well, that's the kind of world we live in, so
yep.
We can only deal with it.
All right, thanks.
Thanks, Dimitri. So just seeing if anyone else had any questions at this point. I mean, I think as you think of any others, we've heard a little bit about some of the next steps that Tony mentioned 5 minutes ago around building up this community. So if anyone on the call is interested in that, by all means, obviously let Tony know or let myself know or Valery know, and we'll add you to that group, because I think that's certainly one of the outcomes, not just from this the broader work that Antony's described and Valery, but equally some of the recent meetings, and maybe we're reaching a critical or a sort of a coming together of some of the different standardizers that were listed earlier. I'm
also interested, Nick, if I know there are other standardizers out there, I would welcome. If anybody knows of others that I didn't list, please send them to me. I think it will be part of the discussion that we have. We should be looking at all the technologies that are available.
Yep. And we'll certainly share, Ian's just kindly posted a link to the RDA interest group, which we'll also share in the notes, or we can send it out to people if they're interested, because I think you know, we certainly in terms of Open PHACTS going forward, we're keen to you know, with the introduction of Kemble, it certainly is stress testing these types of validators when we're gathering together lots of sort of a broad reach of data from the, you know, the Kemble data set, you know, all 26 or 13 million substructures. So we're certainly keen to carry on using this type of standardizer approach. So that's very important for Open PHACTS going forward in terms of both continuing to use a good standardizer, and secondly the performance of it, because you know, as we perhaps look at refreshes of data more frequently, we'll be interested to see how this could evolve over time.
Yeah, and if you're looking for a set of edge cases that can be really challenging for standardizers, ask Ian Bruno and he will give you a long list.
So one other thing, just to keep going on about, to sort of mention about where we are with Open PHACTS. So this is, as I mentioned at the beginning, our sort of beginning of our autumn series of webinars. We're always looking for people who are interested in giving talks, not necessarily just on Open PHACTS, but we've done, you know, ones related to the broader topic of linked data and data mining, etc. So if anyone on this webinar is interested in presenting some work that is related to this area, or both to chemistry or to the broader pharmacological patent search space, then by all means let us know, and we'll certainly talk to yourselves about fitting that into the agenda that we're building over this next period. And I'll just say a final check to see if anyone else had any comments or questions before we thank Tony and Valery again. Tony or Valery, is there anything else you wanted to mention at this point before we share the material later this week?
Not from my side.
No.
Okay. Well, maybe to allow people to go to their next meetings, we'll close the webinar now. So thank you very much to Tony and Valery for a great introduction and summary of the Open PHACTS CVSP work. And as I said, we'll be sharing the material from today, and if anyone has any follow-up questions, then by all means get in contact, and we'll send through the notice of our next webinar, which should be at the end of November, in the coming week or so. So thank you once again, and have a good rest of the week.
Thank you.
Cheers.
Bye.